Welcome to our deep dive into the world of climate predictions. In this video, we will explore the accuracy of climate forecasts and how many of them have unfolded as expected. From rising global temperatures to the alarming rate of glacier retreat, we will examine key predictions related to climate change and assess their real-world impacts. Join us as we uncover the truth behind the numbers and highlight areas where predictions may have been overestimated, giving you a comprehensive look at what has been happening to our planet. 1. Rising global temperature. Scientists have long warned that the release of greenhouse gases would lead to a rise in global temperatures. This prediction has been remarkably accurate, with global average temperatures increasing by approximately 1.2 degrees Celsius since the late 19th century. The warming trend observed today aligns with forecasts made back in the 1970s and 1980s. The consistent rise in temperature supports the notion that human activities, particularly the burning of fossil fuels, play a significant role in climate change. Many cities around the world have experienced record-breaking temperatures, highlighting the urgency of addressing this issue. As temperatures continue to rise, the implications for ecosystems, weather patterns, and human health become more severe. 2. Melting Arctic sea ice. The decline of Arctic sea ice has been another prediction that has come true. Since the 1970s, climate models have forecasted a consistent reduction in sea ice, and data from NASA confirms a nearly 13% decline per decade in summer sea ice extent. This loss of ice is a clear indicator of the warming climate and has profound effects on global weather patterns and sea levels. The melting ice exposes more ocean surface, which absorbs more heat, further accelerating global warming. This cycle of ice melt and warming creates a feedback loop that could have devastating long-term effects. The plight of the Arctic serves as a stark reminder of the urgency to mitigate climate change. 3. Sea level rise. Predictions about rising sea levels have also proven accurate. As glaciers melt and oceans warm, sea levels have risen by about 8 inches since 1880. The rate of this rise has accelerated in recent decades, posing significant risks to coastal communities and ecosystems. Islands and low-lying areas are particularly vulnerable, facing increased flooding and erosion. This trend underscores the importance of global efforts to reduce emissions and protect vulnerable regions. The accuracy of these predictions highlights the reliability of climate models in forecasting long-term changes. Sea level rise remains a critical issue that needs immediate and sustained attention. 4. More intense heat waves. Climate scientists anticipated more frequent and intense heat waves as a consequence of global warming, and recent years have validated these predictions. Record-breaking heat waves have become more common, affecting millions of people worldwide. In 2023 alone, numerous regions experienced unprecedented temperatures, leading to health crises and economic disruptions. The increase in heat waves poses severe risks to public health, agriculture, and infrastructure. These events serve as a stark warning of the potential future impacts of unchecked climate change. The accuracy of these predictions emphasizes the need for adaptive measures to protect communities from extreme heat. 5. Increased frequency of extreme weather events. While not all predictions about extreme weather events have come true, many have materialized. Scientists forecasted more intense hurricanes, floods, and droughts due to climate change. Although hurricanes aren't necessarily more frequent, evidence suggests they are becoming stronger due to warmer ocean temperatures. Floods and droughts have also become more common, putting pressure on water resources and food security. These changes highlight the interconnectedness of climate systems and the far-reaching impacts of global warming. The partial accuracy of these predictions underscores the complexity of modeling natural systems. It also points to the need for continued research to refine our understanding of climate dynamics. 6. Ocean acidification. As predicted, the world's oceans are absorbing more CO2, leading to increased acidification. This phenomenon has had observable effects on marine ecosystems, including coral bleaching and disrupted food chains. As the ocean becomes more acidic, it threatens the survival of various marine species, particularly those with calcium carbonate shells. Coral reefs, often referred to as the rainforests of the sea, are particularly vulnerable, with widespread bleaching events occurring in recent years. The accuracy of these predictions highlights the interconnectedness of atmospheric and oceanic systems. Addressing ocean acidification is crucial for preserving marine biodiversity and ensuring the health of our oceans. 7. Polar ice sheet melting. Climate models have long anticipated the melting of the Greenland and Antarctic ice sheets. Observations confirm that ice loss in these regions has accelerated, contributing significantly to sea level rise. The melting of these massive ice sheets poses a grave threat to global coastlines, with potential implications for millions of people living in low-lying areas. The loss of polar ice also affects global climate systems, potentially altering weather patterns worldwide. The accuracy of these predictions underscores the need for urgent action to mitigate the impacts of climate change. The continued melting of polar ice serves as a stark reminder of the irreversible consequences of inaction. 8. Shifts in wildlife and plant habitat. Scientists predicted that species would migrate to cooler regions in response to warming temperatures, and this prediction has been validated. Many animals and plants are shifting their ranges toward the poles and higher altitudes in search of suitable habitats. For example, some bird species now breed further north than they did a few decades ago. These shifts in habitats have significant implications for biodiversity and ecosystem stability. The movement of species can lead to new interactions, competition, and even extinctions. The accuracy of these predictions highlights the adaptability of life but also the challenges posed by rapid climate change. 9. Glacier retreat. The widespread retreat of glaciers globally, as forecasted by scientists, has been extensively documented. Iconic glaciers, such as those in the Alps and Himalayas, are shrinking rapidly due to rising temperatures. This glacier loss contributes to sea level rise and affects water resources for millions of people who rely on glacial meltwater. The retreat of glaciers also impacts local ecosystems and can lead to increased glacial lake outburst floods. The accuracy of these predictions emphasizes the need for global efforts to reduce emissions and protect vulnerable regions. The loss of glaciers serves as a poignant symbol of the broader impacts of climate change. 10. Some predictions were overestimated. Not all climate predictions have been entirely accurate. For instance, some early projections about Arctic ice disappearance or population displacement by specific dates were overly pessimistic. These overestimations often stem from underestimating variables like natural climate variability or human adaptation efforts. While these inaccuracies have been used by skeptics to question climate science, they highlight the inherent complexities of modeling future scenarios. The majority of climate predictions, however, have been validated, affirming the reality of human-induced climate change. The discrepancies in predictions underscore the importance of refining models and incorporating a wide range of variables.